Scientists just found a planet that shouldn't exist. This giant somehow survived next to an exploded star, one of the most extreme objects in the universe. And the deeper astronomers dig, the stranger it gets. The object orbits a pulsar. That's the collapsed core left behind after a massive star explodes into a supernova. A pulsar packs roughly the mass of our Sun, or 333,000 times the mass of Earth, into an object only about 12 miles wide. It spins hundreds of times every second, while blasting powerful beams of radiation into space. Anything nearby should have a very bad time, but somehow a planet is still there, and it's not a small one. The giant has roughly the mass of Jupiter, but almost nothing else about it looks normal. The planet circles its pulsar at a distance of only about 1 million miles. For comparison, Earth stays at about 93 million miles from the Sun. Because the orbit is so tight, a full year on this world lasts only 7.8 hours. The gravity there is so intense that scientists think it physically distorts the planet. Instead of a sphere, this world may be stretched into a giant lemon shape because of the pulsar's tidal forces. Then, the James Webb Space Telescope examined its atmosphere, and things got really weird. Instead of common molecules like water vapor, methane, or carbon dioxide, astronomers found unusual carbon molecules called C2 and C3. We've almost never seen such compounds in exoplanet atmospheres before. The planet may be wrapped in thick, soot-rich clouds made of carbon, and deep below those clouds, pressure could be so extreme that carbon crystallizes into diamonds. But the main question isn't even what the planet looks like. It's how it exists at all. Normal planets form around young stars inside huge disks of gas and dust. Pulsars are the opposite of young stars. They explode, flood space with radiation, and unleash particle winds powerful enough to tear nearby objects apart. So, such a close planet shouldn't be there. One possible explanation involves a rare class of systems called black widows. In these systems, the pulsar slowly erodes its companion with radiation and high-energy particles. Over millions of years, the smaller object loses more and more material, as if it's being eaten alive. PSR J2322-2650b may be the survivor of that process. But there's a problem. The chemistry still doesn't add up. Researchers think carbon crystals may form deep inside the object and slowly rise toward the atmosphere as the interior cools. But if that explanation is correct, scientists should see other elements too, especially oxygen and nitrogen. We don't even know what this object actually is. Part of it behaves like a planet. Part resembles the remains of a large star, and one more part doesn't fit any known category at all. So for now, one thing is clear. PSR J2322-2650b doesn't fit any rules, and nobody knows what to do with it. They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple, young and small. And indeed, previously, most early universe galaxies we found were just space babies. blue, and small. They seem to have appeared out of the primordial cosmic soup just recently, and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than 1 billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just 1 to 3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit, even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court. Its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold. But in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true. But they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than negative 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition, and the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, Astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.